Hello everyone, and thank you into our ACI series. Hope you had good time watching the first part into the ACI series. So today's video is going to be pretty short and quick. I'm not hoping to take a lot of time on this one, but again, just want to do a small recommendation that before you really proceed into this series, just make sure that you have watched all the 4 videos or the part 1 of this series and really just try to understand some of the concept that we have learned into some of the past videos. Because starting from this series onwards, things are going to be more hands-on, practical oriented. So where I'm really expecting you to understand or know some of the concept that we discussed in some of the past series, especially like what is EPG, VRF, bridge domain, some of those things. So when we are going to go ahead and create them, you understand what are we doing, what is a VRF, and some of those things. So that's the only thing. So let's go ahead and get started. So today's video is all about the topology that we will be working throughout the series for any kind of hands-on. And if you recall from the part 1 of the series, that to make up a fabric, you would need 3 things. You need Nexus 9K based your spine, some leaf, and APIC. As you can see in this topology, the topology that we will be working throughout. In this topology, I have 2 spines, so I'll be using 2 spine, and in my case, the spines that I'm using are 9508. So we'll have 2 spines, and in this topology I will be making use of 6 leaves. Again, don't worry if you don't have that many number of leaves, or if you have more leaves, it's perfectly fine, and I'll show you some of the topology. But the topology we will be working again will have 2 spine, 6 leaf, and we will be making use of 3 APIC controllers. And if you recall that the spine, we never connect one spine to the another, all the leaf connects back to the spine. So you can see from each spine I have 2 links. So one link connects to the spine 1 and another link connects to the spine 2, which I'm showing with the help of just 2 different color. Black shows that it goes to the spine 1, green really indicates that the connections are going to spine 2, and it's the same for rest of the leaf. Same thing from leaf 2, there are 2 connections, one to spine 1, another to spine 2, and so on. And again, you can see there is no connection, there is no direct connection between any of these leaves. So leaf 1 is not connected to leaf 2, 3, and so on, and same thing vice versa. Now this is like our NXOS part, or the standalone 9K. The thing that brings up all intelligence is the APIC. And as you can see in this topology, we have 3 APICs. So APIC 1, APIC 2, APIC 3. Let me go ahead and quickly update that while we talk so you don't get confused. Let me go ahead and append here APIC 1. Let me go ahead and make it APIC 2, and this is APIC. Again, technically there is no difference, all are same, pretty much exactly, but there are 3 controllers into this whole overall solution, and we'll talk about the clustering and some of those things while we proceed further. So remember, all these 3 APICs are part of one single cluster, and as you can see from each APIC, we have 2 connections. One connects to one leaf, another connection goes to another leaf in terms of redundancy. If we lose one link, or if one of the link goes down, we still have another leaf, another link goes down. Same thing, there are 2 connections from APIC 2 back to another set of leaves. So in this case, I'm connecting APIC 2 to one link goes to leaf 3, another link goes to leaf 4, and similarly for leaf 3, one link is connecting to leaf 5, another link connects to leaf 6. So the whole idea, again, connecting to 2 different leaf, we have a redundancy at the leaf levels. If this whole APIC goes down, we still have 2 more APICs providing redundancy. So the link between the APIC and the leaf is a 10 gig link, and the link between your leaf and the spine, right now for our lab I'll be using a 40 gig link, but they could be 100 gig links too. And again, you can go ahead and read more about this into the data sheet and some of the Cisco's official documentation out there. And same thing, the links speed between APIC 2 and leaf 3 and 4 is 10 gigs. Same goes for the APIC 3. And just wants to reiterate one more time, the connectivity between the leaf and spine is 40 gig. This is our backbone connectivity, and the connectivity between your APIC and the leaf is a 10 gig connectivity. So once you have connected, this is how your topology will look like. Don't worry, I took this from already configured fabric, but this is you will see something like similar once you have configured everything. So it shows you that you have an APIC 1 which is connected to leaf 1 and 2, there is an APIC 2 which connects to leaf 3 and 4, and there is an APIC 3 which connects to leaf 5 and 6. Again, the connectivity between the APICs and the leaf is a 10 gig link. Hopefully that makes sense to you, and just the same thing. Again, as I mentioned earlier in this topology, the topology we will be working will have a 2-spine and a set of 6 leaf with 3 APIC controllers. But again, as I said, if you don't have that many number of leaf, let's say, hey, I just got only 1 spine or maybe 2 spine with only 2 leaf, you can connect your APIC in this way also. So if you see that we have only 2 leaf in this topology, so I have connected my APIC 1 to my leaf 1 and leaf 2. Similarly, I have connected my APIC 2 to leaf 1 and leaf 2, APIC 3 leaf 1 and leaf 2. In this case, we just have a single layer of redundancy where these switches are really backing up each other. In case one leaf goes down, we still have another one, but it's not as redundant as something like this, where if one leaf goes down, you still have another one. Even if these 2 links goes down, you still have 2 more APICs which are operational. While in this topology, there is redundancy, but again, it's not just like our previous the screenshot or the topology that I showed you. But again, this is something you can really work with in your lab or maybe in a production environment if you want to do, if the fabric size is small. And again, this is just on the back end of the APIC, how it really looks like. So you can see on the back end of the APIC, there are multiple ports you can see. So there is a management port that you can connect for the dedicated management, something like configuring your Cisco's management controller or CIMC. And on the back end of the APIC, you can see there is a 10 gig WIC card. I'm not sure if it's clear to you, but it says to fabric, and there is a black arrow that clearly indicates that these 2 SFPs or these 2 10 gig ports needs to be connected to the fabric. And in case of fabric, we are referring that these 2 ports we need to connect back to 2 of our leaf. And as you can see, first port is connected to leaf 1 and second port is connecting to leaf 2. This is a 10 gig WIC adapter from Cisco, and the capacity or the link bandwidth or speed between this is again like 10 gig. So I'm sure now you can go back and go ahead and connect your APIC to this leaf using this particular 10 gig WIC adapter. Again, it clearly says to fabric. Once you have connected your APICs to the leaf, you will go ahead and repeat the same task for your rest of the APICs also, and then you can go ahead and connect your leaf back to the spine. And if you recall from previous videos that we utilize these 40 gig ports, so we'll run a cable from this leaf to one of our spine, another cable from this 40 gig to second spine. Same thing, it goes from leaf 2, will have one cable connecting to spine 1, another cable connecting to spine 2, something like this. So we'll have one cable from one of the leaf going to one spine, another cable to another spine. So once you have connected all these physical connectivity and all, and I'm making an assumption, let's say we have done a discovery. So once everything is done, you can go back to any of your leaf node and you expand the properties. And if you click on physical interfaces, so as you can see in this topology or in this diagram or in this picture, you can see the physical interface. It says Ethernet 1/1. The mode is trunk and it's right now enabled, but see the usage. It's being utilized for controller EPG infra and the status right now up. So whenever you see controller EPG infra, that means on this particular port on this leaf, there is an APIC connected. So wherever you see controller EPG infra, that means on this port you have an APIC connected, and you can see the status being up. Anytime on any of the leaf port, if you see the usage being fabric, that clearly indicates that this port on this leaf is connected to the spine switch. So just to reiterate one more time, anytime you see the usage for a port being controller EPG, that means there is an APIC connected. If you see it shows a fabric, that means this particular port is connected to the spine. So that's how we connect a leaf back to the spine, and we connect all the APIC back to the leaves. We never connect any of the APIC back to any of the spine. So hopefully that clarifies some of the things, how the physical connectivity is done in this lab that we will be working through. And again, we will be working with this particular topology going forward. We will have 2 spines, 6 set of leaf, a 3 node APIC cluster where each APIC is connected to a set of leaf. Between the APIC and leaf we have 10 gig connectivity, and between the leaf and spine we have a 40 gig connectivity. So that'll be all for this video. As I promised, this is going to be pretty quick and small video, but again, just want to reiterate one more time, make sure you don't skip any of those videos. Go ahead and learn some of the basics before you really start watching any of these hands-on. That way you would really get to understand what's going on in the back end. So thank you so much. We'll see you later.